We're going to look at example 6 in our 311 notes. So here we want to look at the rate of the soda being sucked out of a glass, which I already have drawn. The glass is 6 inches tall, and the radius, which I have drawn in, is 2 inches. Okay, so it says the depth of the soda, that would be the height they're talking about, decreases at a constant rate of 0.25 inches per second. So that's what we know for this problem. So since it's decreased, make sure you make it negative 0.25 inch per second. Okay, what we'd like to find is the rate of the soda being sucked out of the glass. That's a volume issue, so we're going to find the derivative of the volume with respect to time. All right, so we start off with a formula. We need a formula for volume. The formula for volume for a can like this is pi r squared h. Okay, our second step with this is to do the derivative, but this side would be no problem. This side, we'd have a little bit of problems because that would involve the product rule because we have two different variables here. The good news here, if we go back to our picture, the height is changing, so we can't plug that in at this stage, but the radius is always 2. That doesn't rely on the height, so we can plug that in since that's constant. So we're going to get pi 2 squared h, okay, which is 4 pi h, rearranging a little bit over there. Okay, now we can go ahead and take the derivative with respect to time. So the derivative of volume with respect to time is going to equal 4 pi as a constant, so it just attaches. And if we take the derivative of the height with respect to time, we get dh over dt. Okay, our third step is to plug in what we know, okay, and we know the derivative of the height with respect to time, so we can go ahead and plug that in. So we have 4 pi times the negative 0.25. Okay, these are gonna cancel out, so we get negative pi, and then we have to make sure that we have the label for volume. Okay, volume does cubic label, so in this case we're gonna have cubic inches, and our time is seconds. Okay, and that is the answer for example 6.